Hello there, and welcome back for the next video in Module 1. And I believe this may be the last video for Module 1, if we can get through all of this in one video. We are still looking at scientific inquiry, and the first chapter we did was on investigation design. We did analyzing research, evaluating the results, and now we're up to looking at some relationships between data. So we're going to be drawing some graphs on this one and looking at some mathematical concepts as well. So this particular lesson may help you on your math test as much as the science. If you want more information in the textbook, pages 30 to 34 will give you a very good practice set for this concept or these concepts. So looking at the first one, this is on a direct relationship, and I'm going to give you the definition and then we'll look at an example in real world language. A direct relationship is a relationship between variables So we're going to have two variables, an independent and a dependent. Remember, variable is something that changes, in which an increase or decrease, I can't spell today, an increase or decrease in one variable causes the same in the other. And I'm going to say the same change in the other. And I know that's a long definition and that's a lot of stuff. So let me give you an example that will hopefully make this make sense. So the first variable I'm going to give you is the independent one. Remember, an independent variable is one I can control. So the independent variable is going to be time running. So I go out to do a run and I'm going to time myself. So I have 5 minutes, 6 minutes, 7 minutes, 8 minutes, and 10 minutes. And I did that on purpose because I want you to realize that you may be missing data. It doesn't have to go exactly in order, so you have to really pay attention. Did you notice that I left out the 9? So don't assume. Make sure that you read very carefully about your numbers, what you're looking at. So independent, I can control my time running, and I'm measuring that from 5 to 10 minutes, but I did not do a measurement at 9. Okay, the dependent variable, something that would depend on how long I run. In this case, is going to be my heart rate. So as I'm running, I will measure my heart rate or allow my watch to, and that's going to give me some idea of what's happening in my cardiovascular system when I run. So the first time I measured was at 5 minutes, and my heart rate was 120 beats per minute. So 120 beats per minute is not bad for running. That would suggest to me that a person's pretty healthy to have a low heart rate. If it were 220, I would be concerned about this person's health and would stop running. but 120, it's not too bad. Then 129 at 6 minutes. I would expect that because as I continue running, my heart is going to continue to beat harder and harder, or maybe not harder, but faster. So my beats per minute are picking up because my running time is picking up. And I'm just making up these data. It's not anything that I've actually measured. I'm just making them up off the top of my head. But here's what I want you to see. That the relationship here and here is direct. And you say, well, how do you know that? How can you tell that it's direct? And this is how. My running time, 5, 6, 7, 8, 10, is increasing. It's going up. It's getting bigger. 120, 129, 136, 143, 149, those are also increasing. So they're both, as they continue this way, they're both going in the same direction. Same thing. They're the same. That is called a direct relationship. Okay. Let me show you inverse and you'll see the difference. An inverse relationship is a relationship between variables in which an increase or decrease in one variable causes the opposite effect in the other variable. And that's an effect with an E. And I know that's a lot to write. I am sorry. This will get better in the next module. We're still going to have definitions, but there will be other things too. Okay, so to show you an example of this one, first I need you to remember one thing about this story. I have $1,000 per month total. Okay, and I used 1,000 because that's a nice round number that we can use for some mental math. So my independent variable, which remember that's something that I can control, is my spending. How much of that 1,000 do I spend? And then my dependent is going to be how much of that 1,000 do I save. So if I'm not spending it, I'm going to put it into the bank. And my savings depends entirely on how much I spend, because the more I spend, the less I'm going to have to save. So here's an example. $500 I spent. So how much did I save? If I spent $500, I saved $500. And that 500 plus 500 is the 1,000 for that month. So maybe the next month I spent $600, which means I only got to save $400, because 6 plus 400 is the 1,000. Next month I spend $700, so I can only save $300. I spend 800, I can save 200. If I spend 900, I only get to save 100. So if we study this pattern, this relationship here, I've got increase and decrease. So one of them's increasing and one of them's decreasing. 5, 6, 7, 8, 9 is increase. 5, 4, 3, 2, 1 is decrease. Okay, so this one's getting bigger, this one's getting smaller. Those are opposite directions. One is increasing, one is decreasing. Those are opposites. That is an inverse relationship. So you can see the difference between direct, where they're both doing the same thing, and inverse, where they're doing the opposite thing. Okay, a linear relationship. And I'm going to give you these definitions, and then I'll show you an example of these also. And I think I just hit my, well, somehow I have erased part of that line. Anyway, linear comes from the word line, and you'll see that in just a minute. Just hang with me here. A linear relationship is a relationship between variables that indicates a constant rate of change. And you'll see what I mean when I show you the pictures. A constant rate of change. And then a nonlinear or not in a line relationship is a relationship between variables that indicates the rate of change is increasing or decreasing. So it's not constant. It's changing. It's varying. And again, I'm going to show you an example of that in the next, on the next page. So let's start with a linear example. And before we get to the graph, let's take a look at the table. That's where the data is given. And notice that I have study hours. I'm going to try to pull this down just a little bit. I'm not sure that that's going to work. Yes, okay. So I have study hours and points gained. So maybe I'm preparing for an exam, and I'm going to decide on how many hours I need to study. And I know that if I increase my study hours, what would you expect to happen to my scores? If the study hours go up, the points will go up. That depends on how often I study. This is a direct relationship. You've got both of them increasing. But the question is it linear? Is it a constant rate of change, or is it bouncing around all over the place? And that's where the graph is going to help us to visualize this very clearly. In science, it is appropriate to put independent variables on the x-axis, which is this horizontal side to side, east to west axis. So the independent variable, the thing that I control, is my study time. And so you can see that I have marked off this scale for you already, just to save a little time. Those are my study hours. So we would need to say that my study time in hours is the independent variable. Okay, the dependent variable, that's this axis, is the points that I'm going to gain. So depending on how many study hours I do, I want to be able to predict how many points that will be on the test if my prediction is true. And we've scaled those again also from 0 to 50. So the first point that I need to plot is 0, 0. That's 0 study hours and 0 points. In other words, if I don't study, I'm not going to get any points. If I do 10 hours, I can expect to get 5 points. So 10 hours up to 5. Here's the 5, 10, 15, 20, 25, 30, 35, 40, and 45. So 10 hours, 5 points. 20 hours, so over to 20 and up to 10. 30 hours and then up to 15. 40 hours and up to 20. And here's where the term linear comes from. I have plotted those points, and here comes the line. I'm going to draw a line through those points with a straight edge, and you can see that this is a constant rate of change. That line is perfectly straight. That is a line. It's a linear relationship. Linear means constant change, constant rate of change. Okay. So this is linear. That perfectly straight, beautiful line. I love these because they're just so nice and neat. That is a linear rate of change. So let's look at a nonlinear. What's going to happen if that rate of change is not nice and pretty and straight and neat? I still like these, but that's... Okay, remember, the independent variable is going to go on the horizontal axis, and the dependent variable is going to go on the vertical axis. And in this particular one, these are not really dependent and independent. They're more just showing you a relationship between two variables. The months are listed across the bottom, May, June, July, and August. And then the income is listed up the vertical axis in thousands. So I have 10,000. This would be 15,000, 20, 25, 30, 35, 40, 45. And I left those blank because I wanted to do that with you. I wanted to make sure you know how that is scaled between each of those. Okay, so the first one, it says for May, my income was $25,000. So 1, 2, 3, 4, 5. For the month of May, I go up to 25,000. Then look what happened in June. I dropped way down there to 10,000. And then July, things got a whole lot better. I went back up to 40,000 for the month of July. And then in August, I've dropped a little bit, not terribly bad, down to 35,000. So maybe this is income for a car salesman or a real estate company, someone whose income could vary from month to month. So then you want to connect your dots in order. So May to June, June to July, July to August, and that's all we have to look at. But do you see that this is non-linear? It's not that nice, perfectly straight line. It is bouncing around all over the place. So this is a non-linear relationship. It's also called variance or variable because it changes from month to month. It's not as predictable as that top line would be. And you can clearly see the difference between linear and non-linear there. And this is completely unrelated to this concept, but I want to ask you something. Would you want this job, this person whose income is shown here? And at first glance, you might say no. There's no way, because at one point he's making 25,000 and then it's down to 10 and then it's up to 40 and then it's down. But here's what you have to look at, and this is the importance of labels. How often are we measuring the change? I would agree with you that if this were a yearly income, this line would not be as good, because it would be hard to raise a family on this kind of variance if you were doing this by the year. But guys, we're looking at the months. We're not looking at 4 years. We're looking at 4 months. So what if I wanted to get his total income? We know it's variant. We know it's bouncing around everywhere. But how would you get the total? Well, you would have to say 25, and I'm leaving off all the zeros because it's all in thousands, 40, and 35. So for 4 months of the year, this 4-month section of the year, how much did this person make? Well, 25 plus 10 is 35, plus 40 is 75, plus 30 is what, $110,000 in 4 months. So even though this income is variant, because we're talking about months, that puts a whole different slant on this picture. This is a very good income, in my opinion, for 4 months. If it were years, it would be a little bit harder to say, but you have to be careful about your labels. That's why it is so incredibly important to put those labels in there. What is the income? And down here, you're looking at months of the year. So just a little lesson there on the importance of labeling things correctly. All right, 2 more terms and we'll stop this video. And these are pretty short terms. So a prediction is a specific belief about the hypothesis. So let me go up here to this first graph. What would your prediction be if I studied 60 hours or 50 hours, sorry? Do you think that line would continue to go up or would it not go up? I would predict that it would go up. The more I study, the more my points are going to rise. So that's my prediction on that one. This one's a little harder to predict because we're bouncing all over the place. So this prediction would be a little tougher to do. But a prediction is a specific belief about what's going to happen, about the hypothesis. And a trend is a pattern. In the linear example, the pattern is very clear. It is increasing at a specific interval. It can also be a prevailing tendency. In the second graph, the trend is a lot harder to spot, if there even is one. It would be hard to say because it's variant. But in that top one, the trend is increasing. That is a definite pattern to that graph. So those are some terms that you can relate to these experiments and their graphs. Again, this is as much a math skill as anything. So I think this will help you in the science. It will also help you on the math test. And it's just good for your reasoning skills to study these. Okay, we have finished the first module, which is the scientific inquiry. In the next one, we'll be looking at Earth and space science. So there will be more definitions, but a lot more diagrams and things that aren't quite so boring. So congratulations on making it through the first module. I'll see you in the next video, and we'll look at our Earth and its atmosphere. It's one of my favorite chapters, so I will see you soon.